Hello friends, today I will discuss retardation test problem. Before discussing this problem solution, let me briefly discuss about what is retardation test. In the retardation test, DC shunt motor is used. Here there are two stages. One stage is, so we connect the armature terminals to the supply with its field excitation directly connected across the supply. Then we apply the voltage slightly above the rated voltage. Then we automatically the motor reaches speed higher than the rated speed. Then we disconnect the supply to the armature. Then we take the stopwatch and we wait until the voltmeter shows the 95% of the initial voltage applied to the motor armature. Then whatever time that it takes to reach that 95% of the voltage applied at the beginning, then there is another test. In this test, again we connect the armature terminals to the supply and we apply the voltage slightly above the rated voltage. Then the motor will automatically attain the speed more than the rated speed. Now we suddenly disconnect the supply to the armature and we connect those armature terminals to the known resistance. Now at the beginning of the connecting the armature to the resistance, we note down what is the voltmeter reading and also what is the ammeter reading. Then we allow the time until the voltmeter shows 95% of the initial voltage. Then whatever time it takes up to that time, up to that 95% of the initial voltage, we note down it. Then we calculate what is the stray loss from these readings. And also, depending upon the data given, we also calculate what is the efficiency of the motor. So in the present problem, what he has given is, he gave the two test results, that is when the armature is directly connected across the supply and then removed, that is when the initial voltage applied to the motor is 240 volts, then disconnected from the supply, then he allowed to reach the voltmeter 220 volts, and for that he uh, took the time piece reading, that is 25 seconds. Then again he connected the armature to the supply and applied more than rated voltage, and then it is suddenly disconnected from the supply. Then the voltmeter is allowed to reach the 95% of the initial voltage, that is 95% of 240 volts. Somewhere around you will get 220 volts. And for this, whatever time is taken, that is noted down. That is 6 seconds. So here, average reading of the ammeter means at the beginning when the armature is connected to the resistance, there will be a current flowing, that is I1. Similarly, after 6 seconds also we get another current, that is I2. The average of that I1 and I2 is shown here directly as 10 amperes given. Then he also given the armature resistance, that is 0.3 ohms, and also field winding resistance 200 ohms. And what he wants is, what is the efficiency of this DC shunt motor if it operates at 250 volts by taking 25 amperes. When the problem is like this, if you do not know the retardation test results coordination and the formula, then what all we can do is, With this data, we can calculate what is the input to the motor, and also we can calculate what are the copper loss in the motor. So here we know the what is the input voltage, that is 250 volts, and we also know the what is the input current, that is 25 amperes. So input to the motor is V into I, that is 250 into 25, we get 6250 watts. And we know what is the field winding resistance, that is 200 ohms, and we know the applied voltage, so we can calculate what is the field winding current, that is 250 divided by 200, then we get 1.25 amperes. You know the input current here and we know the field current here. Applying the KCL, then we get what is IA. IA is nothing but IL minus ISH. That is what I have written here. That is 25 minus 1.25, then we get 23.75 amperes as the armature current under these conditions. We know the armature current and we know the field current, so we can calculate what is the total copper loss in the motor, that is Ia square Ra plus ISH square into RSH. So that is what we have done here, 23.75 square into zero point 0.3 plus 1.25 whole square into 200. Then we get 1208.02 watts as the total copper loss. So up to here, whether you know the retardation test or not, we can calculate. So then, if you know the retardation test, then only you can calculate further steps. So look at this, stray loss. Stray loss is nothing but W into T2 divided by T1 minus T2. This W is nothing but V average and I average. So as I told at the in the readings, so here we have the average ammeter reading, that is I1 plus I2 by 2 is nothing but this, and similarly you know the input voltage at the beginning and also at final stage, that is 220. So that 240 plus 220 by 2 into 10 will give you what is called W. That is what we have written here. Into T2. What is this T2? It is second test time. That is 6 seconds divided by 25 minus 6. This 25 seconds comes from the first test. So when you calculate this, then we get stray loss as 726.31 watts. What is the stray loss? Stray loss is nothing but iron losses plus mechanical losses put together is called the stray loss. So we know the copper losses and we know the stray losses, so we can calculate what is the output of this motor. You know the input that we have already calculated, that is 6250 watts, and just now we calculated stray loss and also total copper loss. So subtract those losses from this input to the motor, then we get what is called output, that is 5041.98 watts. So once you know the output and also the input, then we can calculate what is the efficiency. Efficiency is nothing but output by input into 100. So output is 5041.98 divided by 6250 into 100. Then we get 80.67%. To know the theory behind it, you can refer a video by same author, that is retardation test on DC shunt motor by same author. Okay, right.